Hello, the purpose of this section is to continue our learning, and this time we're going to explore solving equations that involve fractions, because fractions are our friends. So here we go. We're going to look at four different examples that involve equations with involving fractions. So here's the first one. 2/3 of x equals 5. And I'm going to show you or share with you two different methods, and you pick whichever one you think works best for you. The first method is opposite operations, and it's a lot of what like we've been doing so far. And the other one is rewriting the equation. So let's take a look at the first one. Well, if we look at the equation originally, we notice here that we have 2/3 multiplying x. So if I'm going to do opposite operations and the 2/3 is multiplying, what I will do is the opposite, which is dividing. So I would divide the whole equation by 2/3, the left side, and of course I have to do it to the right side, like this. The good news is that when I divide 2/3 by 2/3, I get 1, which basically cancels it out. And it doesn't matter what the fraction is, I at the end up very easily with my x isolated on the left side. So I all have to remember that on the right side, I have to divide 5 by 2/3. And I just remember that dividing by a fraction is the same as multiplying by its reciprocal. So on the right side, I will have 5 multiplied by 3/2. Notice how we we've reversed the order of the numerator and denominator, and then we multiply by 5. So in one step, or actually two steps, I have my variable pretty well solved. All I have to do is multiply 5 by 3/2. And of course, I can think of these as 5 times 3 over 2, or 15 divided by 2, or 3/2 5 times, which would be 15/2. So that is the first method. The other method is similar, begins with re-looking at the equation like division. So 2x divided by 3 equals 5. So then applying our opposite operations, our first idea would be to multiply everything by 3. And when we do that, of course, we cancel the 3 in the denominator on the left side, and it just multiplies on the right side, and we arrive very much at the same place as before. Now we have 2x equals 15, which is an equation that we can solve almost by inspection, or we just can see that if I divide both sides by 2, I arrive at the final answer, which of course is the same as the other method. So whichever method works best for you, just use it. Dividing by the coefficient, divide both sides, and remember that when you divide, you really multiply by the reciprocal, or rewrite the equation so then you can cancel the denominator and then divide by the numerator, whatever you prefer. Now we have a different example here. It looks similar to some of the equations we've done before, except that this time we have an extra term. So this time we have x over 2, or 1/2 of x minus 4 equals 10. Well, we can do, it looks a bit like our cups and our blocks. So I would probably get rid of the 4 on the left side by adding 4 to both sides. And when I do that, of course, that on the left side just leaves me x over 2, or 1/2 of x, and on the right side 10 plus 4 is 14. And this one we can almost solve by inspection here. What number divided by 2 equals 14? And if you said 28, you would be correct. So this very friendly way to solve it, we just isolate the x divided by 2, and then we could also have multiply both sides by 2, but we arrive at x 28 as the answer. Example 3. Now I'm going to let you in on a little secret. There's many methodologies to solve equations with fractions, but one key idea is that if we multiply an equation on both sides by the common denominator, it will help us eliminate the fractions altogether, which is facilitating our solution. So if we look at this equation, 1/6 of x minus 2/3 of x equals 5. we can see that the denominators are 6 and 3. And very quickly, we can determine that the common denominator could be 18. Beautiful. So I could multiply everything by 18, but I also notice in this specific case that 6 can be used as a multiple, as a common denominator. So why don't I multiply both sides by 6? And when I do this, uh, I do have to be mindful that the 6 multiplies each term. So 6 multiplies the x divided by 6, and it multiplies the x multiplied by 2/3 over 2x divided by 3. And of course, it multiplies the 5 on the other side. So let's look at it term by term. When I look at 6x divided by 6, I can see that the only thing left is going to be the x. And then when I do 6 times 2 divided by 3, that's 12 divided by 3 equals 4. Or I can think 6 divided by 3 equals 2, and then multiply by 2x equals 4x. Of course, is negative. And on the other side, I have 30. So after this step, this is what I have. And no more fractions. X minus 4x equals 30. I can see that on the left side, I can group my like terms and end up with negative 3x equals 30. And again, we can almost solve this one by inspection. What number multiplied by negative 3 gives me 30? But I can also do a division. I can divide everything by negative 3 to cancel out the negative 3 multiplying as coefficient on the left side. And when I do that, of course, the negative 3 multiplying and dividing on the left side cancels, and I end up with 30 divided by negative 3, which is negative 10. Okay, now our final example. We have equations that involve fractions, but also have the variable on both sides. You know what? It looks daunting, but it's really no biggie. I'm going to share with you two methods. One that we already kind of have seen, which is multiplying by the common denominator, and another one that is kind of abbreviates multiplying by the common denominator, that is cross multiplying the denominators. So here's the first idea. We see that the fractions have a common denominator of 10, then 5 and 2. So if I multiply both sides by the common denominator of 10, I end up with a situation like you see here. So let's analyze term by term. On the left side, I would have something like 30 divided by 2x, 33 times 10. And on the right side, I have to be careful about something. I'm going to divide 10 by 5, which produces 2. But that 2 is multiplied by the whole expression 1 minus 3x. It's not just multiplied by the 1, it's multiplied by both the 1 and the negative 3x. It's just distributed property in a way. So this is what we have after the first step. 30 divided by 2 over x equals, now 10 divided by 5 is 2, but the 2 multiplies both the 1 and the negative 3x. And then I can rewrite this very simply. 30 divided by 2 is 15x on the left side. And then on the right side, I distribute the 2 to end up with 2 minus 6x. I'm going to pause this method for a moment and show you the key idea of the cross multiplication method. So as the name implies, we cross multiply. We multiply the denominator of one of the left side by the right side and multiply the denominator on the right side by the whole left side. This has the same effect as multiplying by the common denominator. So this is what our equation would look like after this step, which is a lot like the equation on what we did on the first step. So 5 times 3x, and then 2 multiplied by 1 minus 3x, which looks a lot like what we had before, which ends up literally at the same place as our previous step. Same story, we have to be mindful to distribute that 2 by the 1 and by the negative 3x. So really, after these steps, we're in the same place. After this, it really doesn't matter what method you chose to solve the equation, then the steps would be very much stuff that we've done before. So in this case, we could add 6x on both sides, because on the right side, then we would eliminate that negative 6x. And then on the left side, we end up with 21x on the right side equals 2. And then that virtually tells us that our answer would be everything, both sides divided by 21. That produces x equals 2 over 21. That happened to be a fraction. But of course, we know fractions are our friends. So I hope this was useful. And now we're going to do a little bit of practice.